Hello, pre-calculus students. I am going to be going over the Chapter 6 closure. So starting with this first one, we are going to talk about solving triangles. So either SOHCAHTOA if we have a right triangle or law of sines or law of cosines. This is a right triangle. I want to find x. 20 is opposite x. 12 is adjacent to x, right? The side across from the right angle is the hypotenuse. So how do adjacent and opposite relate to the x? Those are tangent. So the tangent of angle x equals 20 over 12. And whenever I want to find the angle, I'm going to have to use the inverse. So to undo tangent, it's that I have to take the inverse tangent of both sides, right? So the inverse tangent of the tangent is just of x is just x. And then the inverse tangent of 20 over 12, we're just going to put that into our calculator. So 59.04 degrees. On the test, it says to round to the nearest hundredth, so I'm going to round to the nearest hundredth. All right, so this one I want to find x. It's not a right triangle, so I can't use SOHCAHTOA. So I'm going to try for law of sines or cosines. I always look for the law of sines first because it just is a little bit faster. So the 80 degrees is across from the side I want. In order to be able to use law of sines, though, I need a pair where I know both the side and the angle. 10 is the only other side I know, so that means I need to know the angle across, which I can figure out by adding up the two angles I have and subtracting from 180. So this angle is 35. So my ratio would be the sine of 35 over 10 equals the sine of 80 over x. It's always the sine of the angles over the sides across. And so then to solve this, we multiply the diagonals together and set them equal. So I would have x times the sine of 35 equals 10 times the sine of 80. And then to get the x by itself, I would divide off the sine of 35. I wait until the end to put this all in so that some people want to put this in and round and put this in and round and then divide and then you round again. So you've rounded 3 times. If you just wait until the end and then put this whole thing in, you round once, it's more accurate. Okay, so that's 17.7 units. All right, so looking at this next one, I have this angle and the side across, but I have no other angles. So I don't have another angle in the side across. I can't use the law of sines. That means I need to use the law of cosines. In the law of cosines, there's only one angle, and that's angle C. So then that means this has to be angle C. The side across from angle C is little c. And then it really doesn't matter which is A and B because when you add things, the order doesn't matter. So I could call this A and this B. So I'm looking for x. So x squared equals 6.5 squared plus 7.1 squared minus 2 times 6.5 times 7.1 times the cosine of 119. Okay, and I would literally just put this whole thing in my calculator all in one step, and you get 137.41. And then to get x, you would take the square root of both sides. Now, it's not exactly 137.41. So in my calculator, when I'm doing this, I would do the square root and then I would hit the answer key. So I'm taking the square root of that entire answer. So I'm getting 11.72. All right, this one I'm given the area and asked for a missing side. So we had an area formula where when I don't know the height. And so that formula was half of the product of any two sides of the triangle times the sine of the angle included between those two sides. So the angle I have is 28, and it's included between the 15 and the x. And I know the area. So I can put 60 in for the area, and then I can put 15 and x in for my A and B times the sine of 28. And then I just want to solve that equation. So there are a few different ways you could do it. You could multiply the half times the 15 and then divide by that. You could double, like get rid of the half by multiplying by 2. There's more than one way to solve this equation. I'm going to regroup my 15 and my sine of 28 together because those are both numbers and x is a variable. And so then I really want to get rid of the 15 and the sine of 28 to leave the x by itself. So I would just divide by all of that in one shot. Right, you've got that key on your calculator, like the fraction bar key, so that you can enter that in. So you should get about 17.04. Right, and these are lengths, so units. We don't know what the unit was. All right, so then vectors says determine the magnitude and direction of each vector. So magnitude is the square root of a squared plus b squared. And our vectors can be written in one of two forms, regular component form, a comma b, or that a times vector I plus b times vector j form, which I see popping up a couple of times. So if you're noticing that and kind of getting a little bit nervous, you can just rewrite it in the AB form. So this is the same as having like the A being -1, comma 2. Here there's no I, so it must have been that the A was 0 and then 3 root 2. Here, this is the same as having 3/5 comma -4/5, right? So when you see that, if it's making you nervous, just put it in regular old component. And then to get the angle, it's the inverse tangent of B over A, but paying attention to the quadrant. So remember, if your angle is, or your vector's in quadrant 1, you would leave it alone. In quadrants 2 and 3, you have to add 180 to whatever you get from your calculator, because your calculator only gives answers from -90 to 90. In vector angles, the directions are always from the positive x-axis, and then the fourth quadrant, we have to add 360. So for part 1 here, for my magnitude, I would do the square root of -3 squared plus -3 squared. Please make sure the negative is in parentheses and then you're squaring it. If you put it in like this, it's going to give you a negative number under your square root, right? Because your calculator thinks you want to square and then take the opposite. You really have to put it in parentheses or think to yourself, well, I'm squaring things, they're going to be positive. So that would be 9 plus 9, which is the square root of 18, which you could rethink of as 9 times 2. So you could rethink of that as 3 root 2, or as a decimal as 4.24. And then for the angle, it's the inverse tangent of -3 over -3. That's the inverse tangent of 1. Really, you could even look on your unit circle and say, okay, that the tangent is 1 at 45 degrees, and then also at 225 degrees. So you could think of it that way. Or from your calculator, it's going to say 45 degrees. But you have to think a negative, negative. If I were to plot that vector from the origin, right, and go horizontally left and vertically down, that's in the third quadrant. So if my calculator is giving me 45 degrees, I have to add 180 to that to make that like in the third quadrant. So it's 225 degrees. All right, so then for the second one, when I go to find the magnitude, it's the square root of -1 squared plus 2 squared. So that's 1 plus 4 is the square root of 5. The square root of 5 is the same as 2.24. And then when I go to get my angle, it's the inverse tangent of B, which is 2 over -1. And then when you put that into your calculator, you get -63.43 degrees. Again, you're thinking, okay, if I were to plot this -2, 1, the vector would be up here. The calculator is giving you this negative angle, you have to add 180. So anything in the second quadrant, you have to add 180. So that gives us 116.57 degrees. All right, for the third one, now this one really you could kind of just think about. If you were to plot this vector, 0, 3 root 2, 0 means you go left or right, nothing, and then you go up whatever root 3 or 3 root 2 is. So the magnitude, the length of that is just 3 root 2. Or if you want to use the formula, your A is 0, your B is 3 root 2. If you square the 3, it's 9. If you square the 2, it's 2. 9 times 2 is the square root of 18, which is the same as 3 root 2, right? We said that over here, just the same as 4.24. Anything though on the axis, it's just going to be like whatever that length is. All right, and then when we go to do the inverse tangent, and you could also, like, if you just like look at the way we have it graphed, you can look at this right here and say, oh, the angle is 90 degrees. If you're like, nope, I just like to stick with the rule, and you put in your calculator the inverse tangent of root 3 over 2 comma 0, it's going to give you an error because you can't divide by 0. But if you look at your unit circle, you have two places where your tangent's undefined, up at 90 and down at 270, because the sign is 0. That's why it's undefined. So when that happens, then you have to, again, you kind of have to sketch it and think about, all right, well, that's going up. That means the direction is 90 degrees. I really didn't leave myself enough room here, did I? All right. So if I were to graph this, well, first, if I were to find the magnitude, it's going to look the same as this one, right? It's 0, 4. It's going to go up 4. My magnitude is 4. And if I did 0 squared plus 4 squared, that would be 16, and the square root of 16 is 4. That's my magnitude. And then if I do the inverse tangent of 4 over 0, same thing happens on this as this one, right? So we kind of know from the sketch we had over here, the direction would be 90 degrees. All right, for 5, let's see if I can squeeze that down here. So magnitude would be the square root of 3/5 squared plus negative 4/5 squared. So if I square the 3, that's 9 over 25. And then if I square this, it'd be 16 over 25. 9 and 16 is 25. So that's 25 over 25. So the square root of 1, which is, and then if I go to find my angle and I do the inverse tangent of negative 4/5 over 3/5, and I put that into my calculator, I get negative 53.13. Okay, but I have to think about what quadrant would this be in, right? So if I start at my origin, I could start anywhere, but it makes sense to help you figure out quadrant to start at the origin. This is positive, this is negative, it would land me here in quadrant 4. Okay, but it's giving me this negative rotation I want from the positive x-axis. That's why we add 360 when we're in the 4th quadrant. Okay, so I'm getting 306.87. All right, and then for this last one, when I go to find the magnitude, so that would be 9 squared plus negative 12 squared, which ends up being 225. The square root of 225 is 15. Okay, when I go to find my angle, so the inverse tangent of negative 12 over 9, and I put that into my calculator, I get negative 53.13 again. And then I think about what quadrant would this be in, right? So if I were to sketch that, right, to the right and down, it's the same as the last one. So it's giving me negative 53.13, but I want this rotation. So again, I add the 360 and I get 306.87 again. All right. So in 144, they are asking us to graphically determine each resultant vector. So I know A is the vector 4, 5, B is the vector 3, negative 3, C is the vector 6, negative 2. So I want to add here, and then here I want to do 2 times B minus A. So my A is 4, 5. I'm going to start, I think I'm going to start here. Let's hope I count correctly. So I'm going to go right 4, and I'm going to go up 5. So here's my vector A. Okay, to that, I'm adding 3, negative 3. That means from here, I have to go to the right 3. So 1, 2, 3, and then I have to go down 3. So that puts me here. Here's my vector B. Okay, and then to that, I'm subtracting vector C. When I subtract a vector, it's the same as adding its opposite, right? So my vector C is 6, negative 2. If I'm subtracting it, it means from the end of B, I need to go 6 to the left, but I need to go up 2, right? I need to think of it as adding the opposite of this. So from here, I have to go to left 6, 1, 2, 3, 4, 5, 6, and then up 2. Okay, so here's my vector. I know it's wobbly. Here's my vector C. Okay, my resultant of all of that is from the very beginning. So here's where I very first started, here to the very end. So from here to here, this is my total. This is my resultant. Okay, so from here to here, to get from here to here, I'm going to the right 1 and I'm going up 4. So this is 1, 4. And now you could check this like algebraically, right? So if you think, if I do A plus B minus C, so for all my horizontal components, if I do 4 plus 3, that's 7, and then 7 minus 6 is 1. And then if I do the same thing for my verticals, 5 plus negative 3 is 2. Oh, I'm sorry, 5 plus negative 3 is, am I having a moment here? Oh, why is this? Oh yeah, I'm having a moment. I'm sorry. I'll tell you, it's 7:37 in the morning right now. 5 plus negative 3 is 2. 2 minus a negative 2 would be 2 plus 2, which is 4. I was thinking it wasn't going to work out here for a second. Okay. But 5 plus a negative 3 is 2. 2 minus a negative 2 is 4. All right, which is what I got, 1, 4. Now for this one, I have twice B. So if I double my B, that would be 6, negative 6. And then minus my A, which was 4, 5. And so really what I'm doing is 6, negative 6 plus the opposite of this, which is negative 4, negative 5, if it helps you to like think of it that way. All right, so if I go to sketch this, so I think I'm going to start here, maybe, so I hopefully have enough room. 6, negative 6, so here would be 6, here would be negative 6 to here. This is my 2B. All right, and then from there I have to go to the left 5, 1, 2, or to the left 4, sorry, 1, 2, 3, 4, and then I have to go down 5, 1, 2, 3, 4. I didn't quite leave myself enough room. There's my vector A, right? This is where I subtracted my A. So my resultant is from here to here, right? So, and if I look at this should be 2, negative 11. So is that what it looks like to get from here to here? Yeah, over 2 and then down 11. So that's my resultant for that one. All right, moving on to solving some log equations. So whenever we're solving anything involving logs or exponents, it's always going to be about switching back and forth between logarithmic form and exponential form. So when I look at this, I see I've got logs over here, right? And then I've got something on the right. So I need to get it into logarithmic form, right? By condensing this using my log properties. And then I can rewrite it in exponential form to solve. So I see these are being subtracted. So our log property for subtraction is if I have the log base b of m minus the log base b of n, I can write it as a single log of m divided by n. So this left side, I'm going to rewrite as the log base 3 of x plus 2 divided by x equals 2. Now this is in logarithmic form, right? So 3 is in the spot of the b, this whole thing is in the spot of the y, this is in the spot of the x. I now want to rewrite it in this exponential form. So 3 to the second equals x plus 2 over x. And then to get rid of that x in the bottom, I'm going to multiply both sides by x. So this will be 9x equals, these cancel, so x plus 2. I'm going to subtract this 1x over here. So I'm going to have 8x equals 2, and then I'm going to divide both sides by 8, and I'm going to get x equals 1. Okay, now this one is, we have to get it into exponential form, and then once it's in this form, I can rewrite it in logarithmic form. So when I look at this, if I were to try to identify what's my b, what's my x, what's my y, this 50 is extra, right? The base is here, the spot of the x is here, the spot of the y is here, but this 50 is extra. I have to get rid of that before I can put it in logarithmic form. So we have to divide both sides by 50. So when I do that, I get 12.5. Now I can say, okay, well, here's my b, here's my x, here's my y, and I can write it in logarithmic form. So I can write log base 1.25 of 12.5 equals x minus 3. And then this you can just put into your calculator. So you get 11.32 equals x minus 3, and then you add the 3 and you get 14.32. Now, the ones in 6-130 here are just a little bit different because I notice I have logs on both sides. So it's not quite that I'm going to be able to get it in logarithmic form and rewrite it in exponential form because I've got logs on both sides. So our rule for this was if I had log base b on one side and also log base b on the other side of something different, that then these had to be equal to each other. But before I can just kind of think of it as, you're not really dropping the logs, but you're just thinking, okay, this has to equal this. Before I can do that, this has to be condensed. This has to be condensed using our log properties. So when it was subtraction up here, it was that we divided. This one is addition. So that means that I have to think of it as multiplication of the x plus 1 times the x. Okay, this one is subtraction. So this one I can think of as division. Okay, and then what I can do is I can set this equal to this, or in here I can set this equal to this, and then solve from there. I'm going to distribute as I'm going here. So I'll have x squared plus x equals 12, and here I'll have x plus 1 over x equals 12, and then we'll solve. Okay, this is quadratic, so I'm going to subtract the 12 over, and then I'm going to factor this. So this is x plus 4 times x minus 3 equals 0. So x is -4 or x is 3. Now, the thing with logarithms is that you can't take a log of 0 or anything negative. And so you really do need to check your solutions if it's a log equation. If I take either of these back to the original and it would have me taking the log of a negative, I have to throw it out. So this -4 is extraneous. I have to throw it out because -4 minus 1 or plus 1 would be -3. Or if I put it in there, it would be negative. Okay, and then this one we're going to solve similar to how we solved that one up above. So I'm going to multiply by x. So I'll have x plus 1 equals 12x. I'll subtract this x. So I'll have 1 equals 11x. And then I'll divide both sides by 11. And I'll get x equals 1/11. All right, here we're given this polynomial and we're asked to graph. Or not graph, we're asked to solve. It says determine the remaining roots. So we're given the graph. So from the graph, I can see I have a solution at -3. That means there's a factor of x plus 3. Okay, I also have a solution here at 1, and it's a double solution, right? Remember, if something bounces, it's a double solution. So I have 2 factors of x plus 1, which if you wanted to, I'm sorry, not x plus 1, it's at 1, so the factor is x minus 1. So if you wanted to, you could multiply these together and divide once. You could actually multiply all 3 of these together. But sometimes people make kind of little mistakes if they do that. So you're almost better off just dividing 3 different times. So I'm going to start by dividing by the x plus 3. I'm going to hope I left myself enough room here. So I'm going to put the x plus 3 on the side, and I'm going to start by putting the x to the 5th in. Okay, and this would have to be x to the 4th times x is x to the 5th. This would be 3x to the 4th. Okay, my x to the 4th just totaled to 1, and I have 3 here. So that means this must be a -2x to the 4th, so that these total to be 1, which makes this -2x cubed. -2x cubed times 3 is -6x cubed. And my x cubes have to total be -4, and I've got -6 there, so this has to be 2x cubed. So then this would have to be plus 2x squared, which that times 3 is 6x squared. See here, my x squareds total up to be positive 4x squared. That means this would have to be a -2x squared. So this is a -2x times 3 is -6x. See here, my x's total to be a -5. So this would have to be a positive 1x. So this would be 1. And then 1 times 3 is 3. And the lights just turned off in here. I'm going to stand up really quick. It's really dark. Sorry. So I shouldn't have a remainder, so I know I divided correctly. All right, now I'm going to divide x minus 1 into my answer. So not again into the original, into my answer. So I'm going to do x minus 1. And I'm going to start with x to the 4th. So this would be x to the 3rd. This would be -x to the 3rd. Okay, my x to the thirds totaled negative 2x to the third. So this must be a negative 1x to the third. And that makes this a negative x squared. Negative x squared times negative 1 is positive x squared. I'm supposed to have 2x squared, so this I need another 1x squared. So be a plus 1x times negative 1 is a negative 1x. Okay, but I need negative 2x's. So this, I need another 1x. So this is minus 1, and negative 1 times negative 1 is 1. So that's what I needed. Again, no remainder. Now I'm going to divide again by the second x minus 1. And I'm going to divide into this. So I'm going to start with x cubed here. So this would be x squared times negative 1 is negative x squared. I need my negative x squareds to equal negative x squared. I've got it. Okay, got it there. I don't need to add anything here. I'm just going to move on to the 1x. I'm going to put that there. Plus 1. 1 times negative 1 is negative 1. Got what I need. So to find the remaining roots, I have to set that. I'm trying to solve this equal to 0. Which some people will be like, oh, I have to try to factor or use the quadratic formula. But you don't have an x in there. I would just subtract 1 and then take the square root of both sides. So x equals positive or negative. The square root of negative 1 is just I. Okay, so these are your remaining solutions. And then your solutions from the graph would have been the negative 3 and the 1. So those are all the solutions there. All right, so here we are asked to graph each of these functions. So for this one, it's exponential. And we're going to think about what do each of these values, like besides the 0.5, that's my base, but what would a negative 3 do to my graph? What would a negative 4 do to my graph? So a negative 3 would move our graph down 3, and the negative 4, the negative is going to flip, right? So we're going to flip. And we're going to like multiply, get stretched out by a factor of 4. So the y's get multiplied by 4. So when we do a log, we often start by making a table. We could do the same thing for something exponential. Like just think of making a table for just the 0.5 to the x. And here I'm going to start with x values. Here I usually start with the y values, but here I've got it set up. I can solve for my x value. So I'm going to put a negative 1, 0, and 1. So if I do 0.5 to the negative first power, right, that's like having 1 over 0.5. How many halves are in 1? There are 2 of them. All right, if I do 0.5 to the 0 power, that's 1. If I do 0.5 to the 1 power, it's 0.5. And then think about all of these are going to have to get like multiplied by negative 4 and then move down 3. Okay, so all of these you have to order of operations. If you're like, which do I do first? Do I move it down or do I multiply? It's that you multiply and then you move them down. Now, often if I have to move down, sort of like when you do a sine or cosine, I would start by, okay, they're all moving down. I've got a new horizontal asymptote. Okay, and I might even just plot these and then multiply them all by 4, negative 4, right? So you could plot even like your parent function of the, from here, like think of it as negative 1, 2, and then 1, and then half. Like you could think about, here's my parent function right here. And now all those have to be multiplied by negative 4. Okay, or you could just plot like literally from this table. Okay, so if I did it this way and this was at negative 2, then it's got to go down to, oh, it was at 2, then it would have to go down to like the negative 8, which would be here-ish, right? And if this was here at 1, it would have to go down here to like down negative 2. And then this would have to come here. So it looks something like this. So it's flipped and stretched. All right, this one for a log, this I know is that I am multiplying by 2, right? A stretch of 2. This is going to the right 2. This is going up 1. So remember what we would do is we would make a table just for the log base 3 of x, kind of ignoring the other stuff, and then knowing that I would have to do these other things afterwards. For a log equation, we would start with our y values and pick negative 1, 0, and 1. We would rethink of this in exponential form. So 3 to the y equals x. So 3 to the negative first is 1/3. 3 to the 0 is 1. 3 to the first is 3. Okay, all of my x's are going to the right 2. So if you like to just do everything in the table, you can. You can think to the right 2, so plus 2. plus 2, plus 2. And then all my y's are getting doubled and moved up 1. So you could think, okay, I'm going to double this. That'd be -2. I'm going to move it up 1. So that'd be at 1, right? So it's that I'm multiplying all these by 2, and then I'm adding 1. Okay. The other option is to kind of shift your axes. So in my axes, it's not being centered off like 0, 0 now. I'm going to the right 2. So I'm going to kind of sketch in to the right 2 and then up 1. And then you could plot these points like just the original. So I could, from here, from my new axis, I could go 1/3, -1, and then 1, 0 would be here, and then 1, 2, 3, 1 would be here. So this would be before the stretch. Okay. And then I could take all those points and I could double them. So here, this was at -1, I would go down to -2. This is at 0, it stays 0. This was at 1, it would double up to 2 and it would get stretched. So this green one is my final graph. Kind of wonky. Okay. Or like I said, you could do 1/3 and then figure out what this would be. This would be -2 plus 1 there. So you can see I plotted it there. All right. So any of those would work. After I'm sorry, 2 1/3, because I'd add 2 to these. So, right, you can see this green point here is at 2 1/3 and then down 1. All right, I'm going to stop there for this video and pick up in another video for the rest.